Hello everyone. I hope I am audible, guys. If you could let me know in the chat box, yes, no, maybe. Am I audible? Yes, no. All right, perfect, perfect. Take care. So, good evening and welcome everyone to the fourth day of our data science bootcamp. My name is Dhananjay, your host for the next 2 days. Before that, I want to ask you a few things. Like, I hope you found yesterday's session with Archit Mittal on the topic machine learning, uh, machine learning informative and engaging, right? I hope so. Uh, and for that, like coding ninja is also excited to help you learn for the next 2 days also. So let me know in the chat box like how many of you are excited for today's session, because Shailaja will be joining in the next 2 minutes. If you are excited for the today's session with Shailaja, just drop in coding ninjas op in the chat box, guys. Come on, coding ninjas op. Okay, all right, perfect, perfect. All right, it seems like Shailaja is already here. Let me add her to the stream. Hey, hey, hi Shailaja. How are you doing?
Hey, Dhananjay. I'm doing good.
Great, great, great. So, guys, we have an amazing guest speaker, Shailaja Mishra. She is a data and applied scientist at Microsoft, and today she will be leading one live project on data engineering with NumPy and Pandas. So, Shailaja, if you could please give a brief introduction of yourself to every data scientist and machine enthusiast sitting over here.
Sure, Dhananjay. So, hi everyone. I'm Shailja Mishra. I'm currently working as a data and applied scientist at Microsoft. Before joining Microsoft, I was working as a data engineer at Fractal Analytics. I got into Fractal Analytics as a campus recruit. I graduated as a computer science engineer in year 2020. So, in the process of switching between Fractal to Microsoft, I got offers from multiple companies. So finally, I decided to join Microsoft, and here I am. I'll be your guest speaker, and I'll be helping you with the understanding of data domain with the help of a real life project today.
All right, thank you, Shailaja, for such an impressive intro. So, guys, let's get started. Shailaja, the stage is all yours. You can start it now.
Sure,
You
sure.
can share your
Okay,
screen, Shailaja.
sure. Just confirm me if you can see my screen.
Okay.
Okay. Can you see my screen, Dhananjay?
Yes,
Everyone?
yes.
Okay, sure. So before getting started to any kind of project, I wanted to give an introduction about Python language. So Python is basically a high-level programming language which was released in 1991. You might have this question like why do we need to learn Python? So for anyone who is aiming to get into data domain, Python is preferably the most important language. There are reasons for that. The first reason is Python syntax is very simple and easy to read. It's somewhere similar to our English language. That is why it comes on top priority when you are going to learn any new language. Second is there is a large community. There is a vast community of developers and users who are continuously developing new libraries and features and making it more efficient. Then it is very versatile. We don't only use it for analysis, we also use for making applications, for web development, for gaming, for scientific computing. So the use cases are very much. And also there are plethora of libraries which are available for different operations. And lastly, and most importantly, I would say that Python can be integrated with other data tools and technologies. There is a technology like Hadoop, there is Spark, TensorFlow, etc., etc. So Python is very much compatible and it can be integrated with all of these. Because of all these reasons, Python is one of the most preferred language and it is indispensable part of the data domain. So if you talk to any person who is a data analyst or a data scientist or a data engineer, anyone who is in data domain, Python is something that anyone should know and understand on the top priority. So that was a quick intro about what Python language is. Now, moving to agenda for today. So just wanted to clear it out that what we are going to learn today are two very important Python libraries. One is called NumPy and second is Pandas. I'll give you a brief about both of these packages, NumPy as well as Pandas. How do we use it? Why do we use it? And once we've understood the concepts of NumPy and Panda, then I'll showcase you a real life example what a data person has to face in his or her everyday work and how do we use these packages to solve business problems. Okay, so let's get started. So first thing that the first package, very important package in Python is NumPy. NumPy is numerical Python. NUM is numerical and Py, as you all know, is Python. So NumPy is the short form for numerical Python. So whenever we have to iterate through arrays, whenever we have to store numbers, there is where we use NumPy. And also there are various other, it is not necessary that you have to use only numpy every time. There are other lists and other data structure through which you can store the numbers, but numpy provides 550 times fastest access to other data structures. That is why we always prefer to use numpy. Okay, now you might have a question to me that okay, I understood the concept of numpy. Now tell me, how would I use it? So in Python, if you have to import any kind of package, what I mean by package is, suppose I have to create a calculator, a very normal use case. Then what will I do is I will go and write a program that okay, a plus b will give you the sum of a and b, a minus b will give you the subtraction result, and so on. But rather than writing the code every time to do the same thing, what we can do is there are already pre-written code for something you want to do. And those are stored inside a package inside Python. So rather than calculating the square root or maybe calculating anything, that is just an example, what we can do is we can call a Python package which and call directly we can use its features. So that is a package. And same is NumPy. So if you want to use NumPy, you just have to write import NumPy and that is it. Now Python will do its own work. You don't need to do anything else. This is how you can import NumPy. Now, first of all, you have to do is importing the package. Once you have imported the package, second thing is how will you use it? Now, the very first example is an array. Like suppose I have a number, I have a list 1, 2, 3, 4, and 5. I want to store this 1, 2, 3, 4, 5 array into a data structure. What I'll do is I'll first of all I have to import NumPy because I have to use different functionalities which are there inside NumPy. So after importing NumPy, what I'll do is I'll use a function called numpy.array. And in there, we can then store these values. And when I go ahead and print this variable, then I see that, okay, 1, 2, 3, 4, 5. These 5 numbers which form an array are now stored in a NumPy array. Normally, we don't use NumPy because it's a 5-letter term. What we can do is we use an alias. What an alias means is rather than using the word NumPy every time, we say import NumPy as NP. So NP is an alias that we can give, but otherwise we can do it in this way also. So that was a quick introduction about one Python package, NumPy. You might have this question again that which is more useful? Like in what use cases would we be using these kind of packages? So like I already told, whenever you have to deal with the data, which is numerical in nature, like arrays, we then go ahead and use NumPy. Now, there is another Python library, and this just keep a note that this is the most important library in Python if you are a data person, and that is called Pandas. Someone calls it Pandas, some call it Pandas. So pronunciation might differ, but Pandas is basically an open source library. What we do here is Pandas offers multiple things that we can use for high performance and productivity. Now, first, fast and efficient for manipulating and analyzing the data. We have a large chunk of data with us. We want to understand the data. We want to manipulate the data. How will we do it? We can use Pandas package. Now, we have data residing into different formats. We might have data into CSVs, into JSONs. Overall, data might come from different resources. Now again, we can use Pandas to load the data that comes from different sources. Now, there are different functionalities. We want to handle missing data, we want to clean the data. So, all of these functionalities are available inside Pandas. So, if you want to go for a one stop solution to all your problems which you want to solve in Python, you can go for Pandas. So that was a quick intro about pandas. Now, again, if you want to use pandas in our Python code, the first and foremost thing that you have to do is you have to import. Like the way we did for NumPy, here also you have to say import pandas, and this is an alias. Why do we go for an alias? Alias is not something that necessarily you have to do, but if you write this, now you have to use only a short word, PD. Rather than writing pandas every time, you can go for PD. Now, Pandas is a package. Remember, a lot of people gets confused between data frames and pandas. So I'll make this easier for you. Pandas is a package. Let's consider package is a suitcase, which has lot of hidden things inside it. So once you say import pandas, it imports everything that is there inside that package. And as per our use case, we can then go ahead and use anything inside that particular suitcase as and when we need. So now we have imported pandas. Now we want to work on data frames. You might ask, what is data frames? Till now, what example I showed you was we had 1, 2, 3, 4, 5 array, which is a one dimensional data. But what about multi-dimensional data? In normal use case, we always encounter multi-dimensional data. Example of a multi-dimensional data is an Excel sheet. We all use Excel sheets in our day-to-day lives. Here we have rows, we have columns, and the data is divided into those rows and columns. This is an example of multi-dimensional data. Now, to store the multi-dimensional data and perform different types of analysis, we need to have a data type which can do this. And this data type is data frames. So inside Pandas, there is a feature called data frames, which we can use to store multi-dimensional data. Okay. Now, theoretically, we understood the concept of data frames. Now, let me show you how we can create a data frame. I already told you, and you should always remember this, that whenever you're working on pandas and NumPy, the first thing that you have to do is you have to import pandas, and then once you have imported it, here we have imported it with an alias. We can then use that alias dot data frame. This is a function that is there already inside pandas package, and this will create a function for you. Here we have not given anything, that is why it has created an empty data frame. Now, this is how we can create a data frame. Let me go show you a real life example of how data looks like and what all things we can do using pandas. Okay, now I have a CSV. CSV is basically comma separated file. If you don't understand the concept of CSV, let's think we have an Excel. Excel has rows, Excel has columns. Now we have a data which is there in a Excel file. We have read that into a data frame. How do we read? Here in this use case, we were creating a data frame. Other way is we already have a data somewhere in Excel, somewhere in other file formats. What we want to do is we want to read that data into pandas data frame. So the syntax for that is you have to import pandas dot read CSV. If it would have been a JSON file, we would have said pandas dot read JSON, and we just give the file location. This is the file location of the file where I have stored this student.csv. I read this here, and when I print this, I see this. Now, the first thing that you see here is this is a multi-dimensional data. It has 1, 2, 3, 4, 5 number of columns and 90 number of rows are there. So here we have rows and columns data. So that is why we have stored it into a pandas data frame. Now, we have the data. Now, in real life, a data domain person, what it has to do is you have the data available in this form. That's it. Now, you have to go ahead to analyze the data to understand the data as per the business use case. So, how will we do that? So, Pandas data frame has lot of functions which are already there, which we can call and directly do our analysis. Let me show you how. First of all, you have a big Excel. What you did was you read that Excel into a pandas data frame. Now my first question to you is, how will you now tell me you have read the data? Now tell me how many rows are there in that particular CSV that you just read. One way to do that is you go ahead and manually see how many rows are there. Pandas had made the work easier for you. There is a function called len, short form for length. You just write the name of the data frame inside the length function, and here we go. Here I see that there are 19 rows that are there in my data frame. Next functionality. I don't want to know only rows. I want to understand number of rows as well as number of columns. So what I'll do is I'll write the name of the data frame dot shape. And now I see it gives me the number of rows as well as the number of columns. So now I understand, okay, this is the overall structure of the data that I have. Now, maybe here in this case, we only had 19 rows. So seeing a 19 row data is very easy. But what if I tell you that your data has 500 rows, maybe 5,000 rows, 5 lakh rows? So will you go ahead and visualize your data just by using a print command? No, that is not something very feasible. So there is a function called head. What head does is you have, let's take hypothetically that this data has 5,000 rows. I just want to see how my data looks like. So if I want to see how my data looks like, top 5 or top 10 rows would be sufficient for me to understand how my data would look. So there is a function called head. Inside head, I will just write the number of rows which I want to visualize. By default, it's 5. So here I have said that data frame dot head 6. So it will give me only top 6 rows that are there in that particular data frame so that I can visualize and then I can proceed forward with further steps. Alternatively, if I want to go for tail means now rather than going for the top 5 rows, I want to see the bottom 5 rows. Here, if you see, I have not given any row number. So, like I said, by default, it is giving me 5 end rows. So, this is something which is very handy when you have big chunk of data and you want to visualize either the top 5, top 10, or bottom 5, bottom 10, or whatever bottom number of rows you want to visualize. Now we understood, okay, this is how my data looks like, number of rows, number of columns, everything. Now let's go deeper. If I go ahead and say data.describe, describe is another function. So what describe does is all the columns which are numerical, it will take those columns. Here we have ID and we have marks. Only these are columns which are numerical, and it will give you a summary statistics of that particular column. What is summary statistic? It will give you count, it will give you mean, standard deviation, minimum value, 25 percentile, 50 percentile, 75 percentile, and max. So for someone who wants to understand the summary statistics of a particular column, like I said, there are multiple ways to do that. One way is you go ahead and calculate all of these 7, 8 things on your own. Other way is I just read the data into a data frame. I just say dot describe. It will automatically pick all the columns which are numerical in nature and give you these details. So that is how Python functions and libraries are very much handy and useful. Okay, moving forward. Now I have 5 different columns in my data. I don't know what are the data types. I want to understand what are the data types of each of those columns. So the way to do that is I'll write the pandas dot data types. It will give me what are the data types of each of the columns, like it has shown here. Okay, another one very useful feature is I want to just know the names of the columns. There are multiple situations where we have like 100, 200 rows that are there in my data. What I want is I don't want to see the data. I just want to understand what are the names of the columns. So here, if you just write data.columns, you'll see all the column names that are there in your particular data frame. Now, we have now understood what all we can visualize from our data using the already inbuilt functions which are there. But now let's proceed one step forward with the actual work that a data person does. You have the data, you understood the data. Now is the time to manipulate the data. So let's take a very simple use case. I had the student data with me with ID, name, class, mark, and gender. My first question for you all is you have 20 student details with you. Just give me the names of those students or give me how many students are there whose marks is greater than 70. These kinds of questions are very much common with the data. So how you can do that? You can directly say data frame, which column you want to filter and what is the condition on that column. So it gives me this particular output that okay, out of all these rows, whosoever satisfies the condition is marked as true, whosoever does not gives us false. But we don't want to see that. We want to see the entire details. So How we can do that? Same function, same condition that we have used. We'll write it inside the name of the data frame. So now you see it gives you only the details of those students whose marks is greater than 70. Rest all student details are not there. So this is how, if you have 5,000 rows, 10,000 rows, any number of rows in your data, you can filter the entire chunk of data as per your condition and visualize for the next steps. Now, now maybe I want to visualize this data again. I'll go ahead and say a head. I can go ahead and say tail. But my major point here is if any data comes to you after analyzing how the data looks like, you can go ahead and filter out the data using such conditions. So that is what I wanted to give you all a brief overview on what actually pandas and numpy are. Before moving forward to the actual project, I just want to showcase you all with very important concept of visualization. Okay, you might ask me that, okay, now I understand what is pandas, what is numpy, and I can do everything using pandas and numpy. So what is the need of visualization? So the answer is that you might have heard about this thing, that a picture speaks thousand words. So a lot of times you might understand the data and everything, but if you go ahead and plot a graph or maybe visualize it using different visualization tools, picture becomes more clear. And how we can do that is, there is a package. Now maybe you, as per my understanding, you all now understand the concept of package. So like NumPy was a package, Pandas was a package, there is another very important and very used Python package that is called matplotlib. Using matplotlib, what you can do is you can plot a lot of charts which will help you to visualize your data. So how you can do that is, you have to import matplotlib, and inside matplotlib you can then import pyplot. And like suppose I have a data 0346 and I have another array 5, 15, 20, 25. So I have two chunks of data which I want to visualize. I want to plot it on our graph the way we do using pen and paper. So rather than us doing that, we just need to mention plt.plot, take the x points, take the y points, and show me. It will go ahead and plot the graph for you, and you can easily visualize the relationship between x and y axis using matplotlib package. So this is one way to do that. There are various ways through which you can plot different graphs. Like here, maybe you want to see a bold line, maybe you want to see a dotted line. So there are different ways to plot a graph. Now maybe you want to plot a bar graph rather than a chart. So you go ahead and say plt.bar. So it will go ahead and plot a bar graph for you. Now, a lot of use case might occur where you want to plot a pie chart. So in that case, you'll say just plt.py, and you'll give your labels as well as the data. So it will plot a pie chart for you. Another visualization tool is a histogram. So you just say, okay, this is my data. You have to ax.hist. Hist is a function which will automatically go ahead and plot a histogram for you. So these are not actually all. There are a lot of visualization tools that are available, but these are the most used visualization tools which we actually use in our day-to-day life to visualize the data that is there. So this is this visualization as well as Pandas, NumPy, Matplotlib. So if you ask me that from a data person perspective, what are the very important Python packages one should actually have a very good hands on, is these three: Pandas, NumPy, Matplotlib. And why I'm telling you this thing, you'll see just in a few minutes. Because now, after giving you a brief overview of these concepts, I'll just start with a proper project where I'll show you how we as a data person actually deal with a real life problem. Okay, so let me start with. So I have taken a use case scenario, which the project title is Housing in London. So let me give you a brief overview about what actually this is. So what we want is, in this notebook, we'll see the housing market of London between the year 1995 and 2020. And what we are going to do is, we are going to perform exploratory data analysis. This term, exploratory data analysis, let me give you a brief about this. So we are going to explore the data that we have and analyze the data. And this is something which is the first step of any data person that has to go to. So here we are going to perform exploratory data analysis, and our goal is to discover the information. So we'll answer two questions. First question is, how has the housing market changed over years in different boroughs of London? You'll understand the concept of boroughs just in a few minutes, and we'll compare it with England. And second is how this, like, how was it affected? So I've taken a use case. We have a data that is dealing with the what are the distribution of houses in London and in England, and we'll then visualize what are the different factors that affect the housing patterns and markets in these two particular countries. So this is just an example project. This is something that we might face in our day-to-day life. There is something we don't even know, but how will we get information from that particular data? That is what we have to go forward with. Okay, so I've divided my entire project into these particular parts. Introduction, I've already covered, like what actually we are going to do in this project. Second is libraries, or what we call packages, which we'll be using in our project. Third is the data sets. What actually is the data that is available to me? Fourth, fifth, and sixth would be the basically how we are actually calculating and moving forward. Okay, so let me start. When you are given any kind of project, the first thing that you have to understand is you have to import necessary libraries. Until you have these libraries, you cannot move forward with any of the functionalities. We already saw that if we want to calculate the length, we want to go get the information, we want to do any kind of filtering, we need pandas. Similarly, there are different libraries we might be using in our project. So first thing, when you're starting any project, you have to import the libraries. And same thing I have also done here. I have imported different packages which I'll be using in my project. That is one thing. Second thing is, what are the data sets we are going to use? So I have used already public available data sets. First is housing in London dataset, which is provided by this person. So I have two CSVs. I already told you the CSVs are comma separated files. There is one CSV called housing in London monthly variable, and there is housing in London yearly variable. Now, it has a lot of details. It has details like average house prices, yearly mean, median salary, all of these details. Second, the data is split by area of London. And now I already mentioned, right? Boroughs are basically in London, different areas are called boroughs, which in our society are called different societies, and different names are given. In London, different areas are called boroughs. Okay, so long story short, we have three different data sets which we'll be using. In layman terms, data set is basically the source data. Like I am a data person, I am only given, okay, these are the three CSV Shelja. You have to process these CSV and you have to give me answer to two questions. This is something that you will face in your real life. Okay, now, like for initially, first thing that we have to do is we have to understand the trend over the years. So we have two different data sets. First is this, second is this. Let's not go into what data set is it. Let me start the actual processing. Okay. So the first thing I already mentioned, when you started a project, you understand what are the different packages that you need to import. After importing all the packages, the first step in any data cleaning is data pre-processing. That is, you have the data, you have to perform a lot of pre-processing. Pre-processing, as the name suggests, is something that you do before processing. Pre means before. So before going into actual processing of the data, you have to do multiple steps that involves pre-processing. What I mean here is, first of all, this is my data. Housing in London monthly variable. And I already told you that this is a CSV. How do we read a CSV? We say pandas.read CSV and we read the data. Now I go ahead and print this data. Now, if you see, I have written something like this. It might seem complicated to you, but what it is showing here is that I am printing the number of rows and the number of columns. So dot shape 0 gives me the number of rows, and dot shape 1 gives me the number of columns. So now I see, okay, this is my data, and I have only printed head because this data contains, if you see, 13,549 rows. And like I said, I don't want to see the entire data. I just want to see how my data looks like. So that is why I went for head. Now I see that there are 7 attributes in this particular data. Attributes as in columns. Now There is a column called borough flag. So whosoever has borough flag equals 1, it means we are only dealing with the data of London area. So this is one way through which you can filter rest of the data. I have like very big amount of data. I only want to pick the details of the city London. So I'll just go ahead and say, give me the details only for those particular borough flag equals to 1. Now, first of all, what I want to do is I want to understand what my data actually looks like. So there is a function called info. What info will give me is, are there any missing values in my data? This missing value check is the first step of any data pre-processing. So I would suggest everyone to keep a note of these things that I'm specifically pointing out. So we started with data pre-processing. I told you, whenever we are dealing with any kind of data, the first step that we have to do is data pre-processing. That is, and under data pre-processing, the first thing is that you have to do a missing value analysis. What I mean by missing value analysis is, we have big chunk of data. Like suppose, let me give you a short example. I have 10 rows, 5 columns. So there might be few columns where there is no data. That might occur because of multiple reasons. When someone was entering the data, they just forgot to fill in that field. There was some error. There might be multiple reasons for that. But at the end, the final data has some missing values in those. So any kind of data analysis that we do, the first check is you have to identify all the missing values that are there. And first is to identify. Second is, what will you do to fill in those particular missing values? So how we can do that? We have a function called info. So I say this is my data frame name dot info. So now what you can see is, I already told you there are 7 columns: date, area, average price, code, houses sold, number of crimes, and borough flag. And this is the details which information function is giving me. I see that these are non-null. These are number of rows which are there, and these are non-null. One thing that you have to see here is, there is a particular column number of crimes, and here you see non-null are 7439, rather than all other are 13549. There are two particular columns you would see which has some missing values. This clearly gives us this particular output. Now I want to understand from this, what I understood is, there out of 7 columns, there are 2 columns where there are missing values. Now, my second question is, how many missing values are there in these 2 columns? How will I do that? There is a function called is null. So you might see me saying every time this thing that there is a function, there is a function. So this again shows that how rich is Python language. You import a package, and that package already has an inbuilt function which will give you everything. You just need to call a function. Otherwise, the other way to do that is, for everything, you need to write a piece of code that will perform that functionality. But in Pandas, all of that code is pre-written in all of these functions. You just need to call the function. Okay, coming back, I have my data frame. I say in my data frame is null. If anything is null, null means empty, then give me the sum of those particular things. Sort values is also one function. This is just for sorting my data into ascending order. And second, this is one particular column that I create. Second thing is, I say what is the percentage that you can calculate, normal percentage formula that you divided by total sum. What is the percentage of missingness? And then I see, okay, this is the particular data. So first of all, I see 1, 2, 3. These 3 columns don't have any missing values because the count of missing values is 0. And the same column that we identified earlier, number of crimes and houses sold. Number of crimes has 6,110 number of missing values, while houses sold has 94 missing values. If I go on percentage, it is 45%, which is a very big number when we are doing any data analysis. While houses sold is 69% of 0.69% of missing values are there. Now, firstly, we have identified the missing values. And like I said, second step is, now you have identified the missing values. What will you do next? One way is, this is the column which has missing values. I'll go ahead and I'll drop that column. But before dropping any column, you have to see whether that column is important or not and how much data is missing. If the missing data is very small, you don't need to actually drop that column. But if the missing data is very big, like in our case, 45% of that particular column data is missing. So we'll go ahead and delete this particular column called number of crimes. But what about houses sold? Houses sold, only 0.69, not even 1% of data is missing. So in other case, when we are not dropping a column, other way is we have to replace the data. Rather than an empty data, we need to fill it up. Now, how will we fill the data? So there are different ways through which we fill the data. Most commonly used way to fill that data is you have a column, you'll calculate the mean value of that column, and you'll replace the empty values with the mean values of that column. You might have this question and you might argue with me that you are changing the value of a particular row. But the answer to that question is, if we have a very big chunk of data, like in our case, we have 15,000 rows, and out of those 15,000 rows, 0.69, which is lesser than 1% of the entire data, if that is missing and if we replace it with mean, there is no significant change that has to happen on the entire chunk of data. So, this decision is upon us, and this is a very crucial decision that while under data pre-processing, on the missing value analysis, you have to analyze how much data is missing, and then you have to decide whether you want to drop the column or you want to replace the missing values with mean, median, mode as per the use case. So, like I said, here, first thing we are going to do is we are going to drop. So, there is a function called drop. You'll just say, okay, this is my name of the function, and it will drop this column. Second, for this particular column, I don't want to drop this column. Rather, I want to fill this column with mean value. So, how will we fill? There is a function already which says fill NA. NA means the data which is empty. And what it will fill is, it will first of all group this particular data and calculate the mean. And then that mean will be then filled into those particular empty spaces. So this is how we have dealt with missing data. So our missing data check is done. That was the first step. Second is that we want to visualize what data do we want to actually go forward with. So initially, if when I showed you the data, one thing that I showed you was date. There's a column called date. So second thing is you have to see what are the data types of each of these columns. You see for date, you have year, you have month, as well as you have date. But in our use case, we don't need the entire data. Only year will help. We don't need to go into month and date. So what we'll do here is we'll go ahead and we'll say take the date from this particular column and keep it in a different place. And you are creating a different column called year. So we had a column called date already. From this column, we have created a new column called year, and we have taken out only the year part of this date. Another very useful functionality. Now, I did that and I want to visualize. So you might ask me, what is this ILOC? This is a very good feature that is there in Python that will give you the location wise data. What I mean is, I have 15,000 rows and I've written give me data which is there at 0 and which is there at -1. So, what I mean is, give me the data which is there at the first row and give me the data which is there at the last row. So, you might see right here the index is 13548. So, if you want to see only the first and the last row of your entire data, this is how you can see. This is just a visualization way. I wanted to see that whether this thing that I have created, creating a new column out of my date column, whether it has implemented or not. And you see here from 1995 1 I extracted only the year 1995. Again from 2020 1 I extracted 2020. Now, this was my data pre-processing. I want to understand my missing data. I want to understand the data type. If there is something which is not correct, I will go ahead and change it. That was first step, data pre-processing. Second step is data exploration. Here is where we go ahead and modify the data to gain some insights. Now, first of all, according to Wikipedia, that there are 33 boroughs in London, 32 plus the city of London. And I already told boroughs are basically small, small area wise divisions which are there in London. And that is a terminology that is used in UK, not in our country. So first thing is we want to identify whether the thing that we have read on Wikipedia is that thing matching with our data set. How will I do that? Again, I showed you how will we filter the data. So now we have a data frame. I have a column called borough flag. I will just say whosoever column value is 1, you just give me the unique count of those particular rows. So by saying unique, it will give me only those values which are non-repetitive or non-duplicate. And then I say length. I see that okay, this is 33. So in that case, our assumption is correct. Second, now, from the entire data set, I want to identify which of the regions are outside of London. So, rather than equals to 1, I've changed my condition. I have said that now borough flag equals to 0 and give me the n unique, number of unique. So, it gives me 12. So this is, and now I want to see which are those which are unique. So I say unique gave me the list. N unique gives me the number because I have written n means number. So these are all the different boroughs which are there in our data set, which is not in London, rather it's outside London. Now, one thing is we have a big data and we are only concerned initially, if you would have if you remember in our introduction, we said that we only want to understand the data that is there in London, and we also want to understand the data which is there in England, and then maybe we want to compare these two data so that we understand what is the trend of houses which are there in these two particular different locations. So first thing is we want to split the data. Split the data as in split London data different and England data differently. So how will we do that? First of all, we have identified that okay, these particular, or I would say there are 12 different locations which are outside London. And this is the list I got. So what I'll do is I'll create a list called England regions. I'll write all these particular locations inside that. And now since I have two lists, I have list of all the London boroughs, I have list of all the England regions. What I'll do is I'll split the data. This concept of splitting is very, very important because there might be a lot of situations where you have a big chunk of data and you want to split the data as per different conditions. So how I can do that is I'll say this is my data frame. In this particular area, you have to put this condition that this particular area is in the London boroughs list that we have created. So this will give me a list for London. Second, my list is ENG. That's a short form I've kept for England. So this particular area is in England region. So now what we did was, like suppose I had 5 rows, 3 for London, 2 for England. So what I did was rather than storing the entire 5 rows in one data frame, I have created two different data frames, named with London and England. London data stores only the 3 rows and England data stores only 2 rows. So that we have two different data frames, and now for each of these data frames, we can do our data analysis differently. So that is why London versus England. Now, first thing in my exploration is I want to understand what is the average price of houses in London and what is the average price of houses in England. So how will I calculate the average price is I'll say go to this particular basically data frame dot group by date, and I want to group on two particular conditions, average price as well as date. So I do the same for those two things. Now, if I give you a list of 15,000 rows and I give you an average price of London and I give you an average price of England, you might be able to understand, you might not. But rather than doing that, I say you, I have calculated the average price of both these particular locations and I'll show you using a diagram or using a visualization tool. That will be better rather than showing you the numbers exactly. So what I've done is there is I already told you that under matplotlib there is a function called plt that you can use, and also if you hover over this, right, it automatically gives you the details. That is something very good feature of Visual Studio, that if I've written plt.figure, I hover over plt, it gives me all the details which is related to pyplot. Okay. Now, what I say is, I have average price of London, I have average price of England, and I want to plot this into a diagram. So first thing, let's just skip this part. I'll show you this. First of all, I give a title. These are all not necessary feature, but I have added all these things so that visualization can be better. So I say this is the title. Second is what will be the label of my y-axis. Then I say, what would be the my configuration of x-axis, x label, y labels, and legend and everything. These are just different features which we can use for uh, beautifying our visual. Now, you see this data. What is better? If I would have given you average price in terms of numbers, or I'm showing you this diagram. Now, let me go deep dive into this diagram. First thing is I calculated the average price. Second thing is I calculated the average price on terms of date. If you remember, I said group by date. So all my years got grouped. So, and then what I say is London should be blue color, England should be red color so that you can distinguish. This is what I have written here. Royal blue for London and fire brick color for England. Now, second thing is I have added two different things here. One is the recession line that I've created, and second is the Brexit referendum that I've had. These were two very big steps in the history of London that actually changed a lot of things. So, if you want to understand the trend, I just place this that okay, at this particular date, add these particular things. So, this is just a UI change that I did. So now you see that over the years from 1999 to 2019, this is the price increase for England, which dropped somewhat here and then it got increased. And if we talk about London, it also increased, but its increase were higher than what England was. Again, the prices got decreased here and then it increased like anything. So this is something I visualize through using this plot, the same thing that I just mentioned here. That what you can see is the average price follows an upward trend. It is always going up. Only two places. One is the Great Recession that came in 2007 to 2009, and second is somewhat in the referendum it got a bit down, but again it got up. So these were two things. So this is the first exploration I did. I only got a data, or I would say I only got an Excel sheet. From that Excel sheet, I came till here. I now understand that for two different locations, one is London, one is England, average price of houses over the years, this is the trend. And for the downfall, I understand okay, this is the reason why it got down. Then I understand how it got up. So, this is the magic of these visualization tools. Now, let me move forward. Okay, now I see that average price of each of these have been fluctuating. Now let me go and identify the mean value. I say I now understand okay, the values have been changing. I only say for London, the value got from here, then it got here, and again there's a lot of fluctuation that is happening. Now let me keep England aside. I just want to understand for London, which I see there are 33 different areas. Let me not say boroughs. I say there are different areas, 33 different areas. In our country, we say districts. In their case, we say boroughs. So I want to understand that London is a big area and we have 33 different areas which are there in London. I want to understand out of those 33, which are the 10 most expensive areas in London where house prices is maximum. How can I get it? I'll say group by my entire data on the basis of area and average price and give me the mean value of that, and then I will sort these value in descending order. How will I say descending order? Ascending equals to false. Now, what you see here is, and I have only kept head, top 10. I only want to see 10. I don't want to see all 33. So now you can see that out of all the areas, first of all, what it did was it calculated the average price of the house. Second is, out of all the areas, we only selected the top 10. So I can see that Kensington and Chelsea, and Westminster. These are the first and the second most expensive areas in terms of house prices in London. Again, a exploration that we are doing on the data. I only had the data. I only had one Excel. I did not know anything about the data. But after doing my exploratory data analysis, I now know that in London area there are two particular areas which are most expensive. Now, I see this thing. Okay, I understand this thing. But like I already said, picture speaks a thousand words. Now let me demonstrate the same thing using a chart. Use the same data, I'll plot it on a chart. This particular line of code, it might look very typical to you, but what we are doing here is we are just giving the details, as in we want to plot this thing. This is what my title should look like. This is what my label should look like. This was what the size should be. All of the looks and feels for the UI. Now, what you can see, these are the top 10 areas, and these are the average prices for the most expensive areas in London during the year 1995 to 2019. And same thing now, when you visualize, you see that this area, Kennington and Chelsea, has the highest. It is way too ahead of all the above. And second is Westminster. And after that, all gets decreasing. Now we have top 10. Let me now just filter top 5. For the convenience, I'll only select top 5. So these 5 are the top 5 which are there for me in terms of house prices. Now, let me plot the top 5. So I now have a list of top 5 areas which are the most expensive in London. Second thing I want to do is I want to see the evolution of the average price through time, which means, like, if I'm saying that Chelsea area has the highest price in London, I want to understand when price increased so much in that entire duration of 1995 to 2019. I want to see the evolution, and I want to see the evolution of top 5 areas which we have figured out. So there is another good visualization tool which we can use for the same. And here, this, if you see, what we have done is we have color coded. Color coding is very much helpful when we are visualizing multiple things. So you see here, we are visualizing 5 different areas. And for each of these areas, I have picked separate colors so that in the graph, you can understand everything very clearly. And how I have done that is, again, I'm using only plot, and here I have used different colors. These are the codes for each and every color which I have created, and I have plotted this. Now, first thing is, what we can infer from this is, again, same thing, that Kingston and Chelsea is the highest in terms of average price, followed by Westminster, then Camden, and so on. That is the first thing. Second thing is, we can see that the evolution that happened actually began so much drastically. It happened after 2009, because like I already showed you in this particular graph, let me scroll a bit up, that in 2009 around, recession came in, because of which prices dropped, and after that it increased again. And same thing you can see in terms of time evolution as well, that around 2019 there was a drop. After that, each of the average prices grew exponentially. This is what the explanation for this particular chart is. Now we understood about London. If you remember since start, what we were doing is we were doing London versus England. So now I'll go here. I'll show you the same thing for England. I'll say, okay, this is my data frame for England. I'll group by on area, and I will calculate the mean value, and I will name it as average price. Again, since I have all the list, I will sort it out in the descending order, ascending equals to false, and then only select top 3 most expensive regions in England. And here I see southeast, east of England, and southwest are the top 3 areas in England which have the highest average price of houses. Now, one way is the same way we did for London, we'll do it for England. One way to visualize this data is to visualize using this particular data, using these numbers. Other way is to go for a visualization tool. Plot, again, matplotlib.plot, pyplot is something that we use very often. You might see me using it for the third time here. I'll go ahead, I'll plot, I'll say that my X label is particularly, this is the date and this is the average price. You see here, my X label is date, my Y label is average price. For X, I've set a size and font size equals to this, and for Y, I've set this is would be my font size. Again, this particular piece of code is doing a group by and mean on the particular data. Now, again, I've done color coding for ease of understanding. For southeast, I have orange color. For east of England, I have blue color, and for southwest, I have green color. So what I have done is I have now plotted the average price for the most expensive three regions from 1995 to 2019. And you see the trend. For the southeast, it's going up. 2009, there is a dip. And after 2009, there's an exponential rise. Same thing is happening. And this plot also shows that this one is on top, this one is on second. Actually, east of England and southwest were comparatively same. This plot is something that will give me deeper information. So if I see this, that from 1995 to 2012 till 2012, I see that east of England and southwest house prices were very much similar, equal. After that, east of England price grew very much higher than southwest, and southwest became third. So these small details gives our we can visualize these small details using these plots. One of this is PyPlot, which comes under matplotlib package. Now, now I want to understand. I see that okay. I have firstly visualized that okay, these are the five different places which are the most expensive areas in London. Then I visualize that okay, these are the three most expensive places in England. I had a big data set. I divided the big data set into two different parts. One was for London, one was for England. I visualized London top 5. I visualized England top 3. Now I want to compare London and England prices. So I will compare top 3 of England with the last bottom. We had the top 5, right? So the fifth one from London. So if I show you here, what I'm doing here is I'm se- I'm s- I'm picking three expensive English region versus the cheapest London area, and I'm plotting this. So here, what I'm showing you is I have southeast, I have east of England, and I have southwest. These are the top three areas in terms of house prices in England: orange, blue, green. If you see, and then I have selected this one. If I go ahead in this particular if you remember right, I told you that we have 33 different areas and we only selected the top. But here what we are doing is out of those 33, the one that was cheapest, the number 33rd one, we selected that particular area and we plotted that here. When one very good finding here, if you can see, is okay, let me ask you guys this question. What is one thing that you see here? Maybe I'm speaking for so long, so I'll just keep a break here. And I have a question for you all is, I have plotted top three areas of England and I have plotted the cheapest London area. And what would be if you are someone who sees this particular visualization, what inference you draw from this particular visualization? Can someone answer this? Drastic change in 2014. Okay, anyone else? English expensive areas are similar, London cheap area very price. True, true. That's what I wanted to understand. And I've seen few people ask. There is a question that what is the use of this analysis? So I wanted to answer this question in between. Is this is something I just took one example here. This is something that we do in our daily life. We are given a data set and we are set to do exploratory data analysis on that particular data, and we have different questions. Like here in our case, the question was, we have a data for London and England, and I want to understand what is the trend of prices which are there in London as well as in England, and there are a lot of sub questions that come out of it. So this is a real life example of data analysis. Okay. Yeah. So coming back to my question here was, and one someone answered it very correctly. You would see that the top three areas in England are very much similar to the bottommost area or the cheapest area in London, which means the prices in London are so high that even the one that is at the lowest is somewhere similar. If you see this red line, right, this is somewhere matching the price of the first, second. If I consider it even at the fourth number, even after 2014, you would see that it has gone above the blue mark of East of England. So it shows that even the cheapest area in London is comparable to the most expensive region of England. So if I'm someone who wants to maybe buy a house or something, then this analysis would be very much helpful for me, because now I understand that buying a place in England, even in the most expensive area, is nearly equal to buying a place at the most cheapest place in London. So that answers your question that why are we doing this analysis? Okay. So this was all about this exploration that we did till now was with the passing of time from the year 1995 to 2019, which are the areas, area wise. We were always dealing with this. If you see the code that I have written, every time I was dealing with the prices of the house. From this area, this is a low price area, this is a high price area. We were dealing with price. That is one way of visualizing the data. Other way of visualizing the data is, now I want to understand how many houses were sold in England, in London, and then maybe I want to compare those. How will I do that? Now, I'll show you another visualization tool. I see that I'll say, first of all, now rather than grouping on different bases, I want to group on a column. If you remember, we already had a column called house sold. I'll do a group by on this particular column and I'll sum it up. Now, I can plot this using, there are different tools. Earlier, we were plotting it using PyPlot. Here, we have a different plot that we have here. So now I want to see if you could resonate with this particular thing. It's kind of a chart which shows the heartbeat signals that is there. So now rather than using a plot, we'll plot it in this AXV line. So what how you see here is that from year 1995 to 2019, how many houses were sold in London. So you see, again, there is a lot of fluctuation that is happening. There is no consistent thing that is there. You see, it got up again, it dropped around 2004, then again it got on the top. Around 2009, it fell like anything, nearly reached less than 4,000 value. Then it got again, it went to the top in this year, and the reason for that is a new tax legislation that happened in UK. And again it went down. So there are multiple inferences which anyone can draw from this particular visualization. First is that the houses which were sold in London dropped drastically during recession. Second is it moved very high during the new tax legislation that came here. And apart from that, it was very much fluctuating around the years. So that is the same thing. That after 2019, if you see one more conclusion that you can draw from here is, just give me a second. Okay. Yeah. Sorry. So here, the second conclusion that we draw from here is that now we see that it was at mark of 16,000 and above. That was kind of an average that was there before recession came in. But if you see after recession, the values got dropped drastically and it has not recovered since then. The highest value touched this value, but it was only one time. After that, the trend is only beyond in the range of 8,000 to 12,000. So that is again one big inference that someone can draw from this. And here after this new legislation, again it got dropped. So this is one thing that we can draw from here. Now, another thing that I want to understand from this particular data is that I have area, I have sum, and I want to understand how many of those were the highest in terms of area. Previously, what we were saying is out of the areas which are the areas where house prices are highest. Now, what we are seeing is out of all the areas that are there, which are those particular areas where we have the sum of like number of houses sold are the highest. So I do again the same thing. I say group by area, houses sold, and I sum it up. Then, after summing it, I see now, if you remember, last time the cities were different. Now, or I would say the boroughs or the areas were different. Here, the areas are different. What were those areas? Those were top five in terms of prices. These are top five in terms of how many houses were sold. Now, let me plot this thing. Earlier, what we were doing is we were plotting out in terms of different charts, different bars, and everything. Now, let me give you one very good functionality that is there in Python. I want to plot something in terms of cities. So rather than plotting it in the form of bar charts, pie plots, and all of these things, why not plot the map of that particular country? So I'll say I want to plot it on the map of London itself. So that is one thing that I'll go ahead and I'll plot it on the map itself. But before that, I have to first of all get the data. Geospatial information is very much important if I want to plot the data into a map. So what I've done is I have read this particular London borough. Ex- and one thing that I mentioned, I saw in the comment was all the datasets link will be provided to you after this session. So don't worry about where we get this data and all of these things. Along with that, I'll be sharing with you this notebook as well, because sometimes listening to all of these things becomes very overwhelming until you practice it on your own. So my advice for everyone is just understand the concepts which I am telling you. You'll get the data set, you'll get the notebook, and you can practice it later. Okay, now going forward, I read another data. Now this is a different data. How I see the data? Now, let me start asking you guys question more. Okay, so I have a data. Now tell me, uh, now tell me, how will I read the data top? How will I read the top 10 rows of the data? I'm expecting this answer to be answered very quickly. So can anyone tell me how will I read the top 10 rows of the data that I have? What is the function? Okay, I see one answer. Head 10. Okay, the answer is correct. So now I have the data. I'll read this data. So yeah, someone is asking me what is GPD. GPD, if I'll scroll to the top, GPD is a Python package that we have already imported here. GeoPandas. Like I told you, now we are dealing with geospatial information. Geospatial information is basically something related to area-wise data. So in order to read that data, we need to, rather than we cannot do directly pandas.read CSV or pandas. Here we have to use GPD. GPD dot read that data, and it will help you to read the data that is available in the form of geospatial information. So that is why we have used GPD. Now I have the data. I've now read the data, and like someone has already told me, if I want to visualize the top rows, I'll just go for head. Now I have the data. I have the geometry as well, which gives me the coordinates, as in which exactly this city, if this is a city, let's say this is an area in London, Bromley. So what is the particular, I would say, what is the particular coordinates on maps where this particular city is located? So now I read this data. Second thing that I want to do is there are so many columns in this data. Do I need all of these columns? First answer to that is no. I'm only interested in few columns on this particular thing. I want to understand what is the area. I want to understand what is the hectares. Hectares is also a measuring unit for area. And third is we want to understand what is the coordinates for that particular city or particular area of London. So what I do is I'll only select area, I'll only select code, hectares, and geometry. So rather than selecting the entire data, This is one way. Write the name of the columns in that particular data frame, and this will filter out only the data out of this column. So if you see now from these number of columns, we have only these number of columns. One good thing which we did not talk about is how we rename the column. Sometimes the data that we get has very typical names in columns, which we don't want to use. Like, for example, there is a column called GSS code. If I'm layman, I don't understand the concept of GSS code. Why not I can rename it to code for my better understanding? So how will I do this? I'll say this is my particular data frame dot rename, and which columns I want to rename. This gives, if you see, there is a thing called columns, which means you can do multiple columns at a time. Here I want to say GSS code, turn it to code, and same thing I said for name, I turned it to area. So now, and also one thing is you can even convert all of your column names to lowercase and uppercase as per your convenience. So for better understanding, this is already in camel case, first letter capital and all letters small. So I convert all of this to lowercase. So I just go ahead and say for this particular column, convert this into lower, string dot lower. Str is the short form for string. In place equals to true. This is also a very important concept of Python. In place equals to true means whatever I'm saying you to do, whatever changes I'm particularly saying, like here I'm saying renaming the column, I'm saying renaming it from name to area, renaming it from GSS code to code. It, it means that on the data set, you are doing some changes. Basically, there is a big chunk of data that you're reading, and there is a column name attached to it, and you want to rename it. So in place equals to true is whatever I'm suggesting, all the changes will be will be applied onto that. It will remain. It is not like only for this step renaming happens, and from the next step you'll again see the same name. No, I'm saying that GSS code is the current name, change it to code, and all the changes that you have incorporated, make it as it is, don't revert back. So that is the use of in place equals to true. So now this is my second data set that I have used. I read the data, I filtered the data, I renamed the column, I converted into lowercase. Here you see everything is in lowercase. Now my data looks very much understandable. Now, now I have understood, now I'm able to see the data. My second thing is I want to understand the average price. And one second. Okay. Yeah. So this is the data that we have. And if you remember, if I go back to this particular data, this is the data that was I was currently using. Okay, a lot of visualizations. Mhm. Okay. This was my initial data that was there for London. Okay. Now, what I want is, I already told you, I have the data. I want to plot that particular data in the form of a geospatial diagram. So what I'll do is, I'll take that data, I'll group that data onto area and houses sold, and I'll sum it up. Okay, yeah. And now I have average price as well as the houses sold. The first thing that we did and the second thing that we did, I'm clubbing those two. If you remember, initially what we analyzed was which are the areas which have the highest average price in London, in England, and in both. Then the second thing was we did was we analyzed which are those areas where the number of houses sold are highest. And now what I'm doing is I'm clubbing these two particular things into one particular data set. I have average price for each of the areas. I have average price. I have houses sold. And then there is one more thing that I did in this step. I told reset index in place equals to true. What I mean here is, so in data frame, there is a very important concept of indexing. And what indexing means is there are two ways for indexing. One is by default, and second is we can actually give the index name on our own. So when we say by default is, like suppose we have a data frame with 5 rows. So what pandas will do that it will start the indexing from 0 and 0, 1, 2, 3, 4. That will be the by default index. That is one way. Second way is we have not provided by default index. Sorry, we have provided index from our own side. We say that index equals to A, B, C, D, E. So rather than using the default index, it will now use our user custom provided index. So this is a way to actually set index. Now, when I say reset index, is whatever index you have placed or whatever it was earlier, whatever state it will go ahead and reset it. Means it will again by default 0 and move on till the n minus 1 number of rows. And in place equals to true means I have asked you to do some changes, incorporate them for all these next steps and hold it as it is. So now what we have done is we have said that you have to reset the index from 0 to 4. This is the area. For each of the area, what is the average price? And for each of the area, how many houses are sold? So this gives me an idea of okay, comparative study of two things, mean as well as sum. These are actually different mathematical functions that we use. We can use average, we can use mean, we can use median, we can use mode, we can use sum. All of these are already available functions. You just say mean, it will do a mean for you. Otherwise, the function of mean is that sum of all the entries divided by total number of entries. If I have to do it that way, then I have to write a piece of code to implement that. But here, rather than doing that, I'll just use a function mean and it will do that for me. Now, if you remember that initially the data set that we read, we said there are 33 different localities that are there in London. Now, I want to confirm whether the data set that I read currently, does this also have 33 different localities or not? So again, I'll say that if you see here, one very important thing, that now I'm using NumPy. You might ask me this question: why NumPy now? Till now, we were using Pandas everywhere. Why NumPy now? So, if in use cases where we don't want to actually go for any kind of multidimensional data, we just want to work with one column, which is of numerical in nature, I'll just go ahead, I'll use NumPy dot particular function, and I can get the data. So what I say is what the area column that was there in my particular data. I want to understand how many distinct areas are there in the new data that I have read. And if I see here, I see the size and I again see 33. So this means that the initial data set that I was reading, there were 33 different locations. The new data set that I have read currently now, it also has 33 locations. So my data is compatible. Unless your data is compatible, you cannot union the data. Union, merge, all of these operations only happens on data which are compatible in nature. Okay, before moving forward, I'll just go back and see if someone has some questions. Ma'am, is it mandatory for mean to be in? Yeah, these are all, see, everything that you're currently seeing on my screen, right? These are syntax and you cannot modify the syntax. So everything that you see here is syntactically correct and this is how it is supposed to be. In place I for changing my, okay. Maybe I answered all of the questions. A lot of people answered head equals to 10. I just did not see. Is it a random selection or the head? Very good question, Krishna. If we have like 10 rows, so top rows, the way it is stored in the memory, right? There is no random selection. The way the data is stored, if I see an Excel also you see number one row, number two row, number three row, right? So there is an indexing that is there. And I already told about indexing. So what it will do is it will take the top 5 or top 10 or whatever number you have placed inside head in terms of index. So there is no random selection. Okay, I already mentioned that the dataset links will be shared. And I request you to if you have any to so if you have any questions, just place it here so that I'll come back in every 5-10 minutes and I'll answer all of your questions. Okay, I don't see any more questions currently. Okay, yeah, I see a question. Please explain why we used NP here. I already mentioned. See, okay, let me give you another example. So NumPy has a limitation. The limitation is that you cannot go beyond one-dimensional data. It only deals with numerical data and one-dimensional data. Inside Pandas, there are two things. We have been talking about data frames, but we haven't talked about one more concept called series. So inside Pandas, you have multiple options. First option is I want to go only for one dimensional data. In that case, I'll use series. Same way what we can do is in NumPy, we can do using pandas.series. Second is we want to go for multi-dimensional data. In that case, I'll go for data frame. And one very big question that a lot of people ask, and I want to just clear it out, is in Python, there are multiple ways to do anything, and no way is right or wrong. You might ask me this thing that why we have used NumPy here, why not we have used pandas here. Go ahead and do that using pandas. I just added it here so that I wanted to showcase everyone that same thing can be done using NumPy as well. Okay. And also, if you would have no one noticed about this thing, I was expecting someone to notice this thing that there is a new function which I did not talked about till now. This is intersect 1D. Okay. If I break this name into two parts, intersect 1D. 1D, which means I am only dealing with one dimensional data. And second part, intersect. So what I say here is I want to intersect two different data sets, and each of those data sets are one dimensional in nature. So if you see here, this is one data frame and this is another data frame. I only select one column of this data frame and I only select one column of this data frame. And I say intersection. If you know this concept of intersection says I have one thing, I have another thing, and if I intersect these two things, give me the common values that are there in both, or I would say anything which is common in two different data sets, give me that is intersect. So that is why we have used NP here. We might have done this using different ways. Like I said, in Python, to do one thing there are multiple options. So this was just a demonstration that if I have two different data sets, one dimensional in nature, I can go ahead, use numpy.intersect 1D function and to identify that, okay, from my first data frame, area column has 33 rows. From my second data frame, area column has again 33 rows. And this I can confer only when intersection result gives me 33. So that is why I have performed this thing. Okay, now we just check this thing and we are good to go. We know that okay, we are consistent with the data because later in time we have to merge the data as well. Now, okay, like I said, I understood this data. I understood this data. I understood okay, these had 33 different areas. This also has 33 different areas. And now I want to merge this data. If you remember, why are we actually merging this data? Let me ask you guys this question. Why are we merging these two data sets? Okay, multiple questions. Meanwhile, I'm answering this question. I would like you to answer this question. And it's just a check to see are you guys following up or not. Why are we merging these two different data sets, data frames, London map and LNDM? Okay, okay. Okay, please ignore here. Then head top five rows excluding header. Now, head means top five rows always. You and dot. When we say header, we mean column names. Obviously, it will not give you column names. Top five means top five rows. Okay. Is it better to use Tableau to illustrate data or Python? Tableau, Power BI are third party softwares which we use for data visualizations. For normal EDA, exploratory data analysis, that we do as a part of data exploration and data pre-processing, we always use Python, different Python visualization tools. Or if I say you in a better way, initial steps we go for Python. Once we have data ready and all the questions answered, and we just want to create a dashboard or visualization tool or anything, we then go ahead and use Tableau or Power BI. Python or SQL, which is better for analysis? Very different use cases. Python is a language which we are using, like different packages and different libraries which we are using for exploratory data analysis. SQL is something that we use for querying the data. So as per use case, we use Python or SQL. There might be a lot of situations where we can use alternatively Python and SQL, but that is very use case specific. Say data is not multidimensional, and if we use NumPy, would it increase? If data is not multidimensional, we cannot use NumPy. For normal, is it SQL for big data? Python is. Ma'am, can you say how to use Jupyter Notebook in VS Code? Nothing. You just need to download a Jupyter Notebook, and if you're opening it, open in VS Code. That's it. And in order to run each and every cell, you just need to press Shift Enter, and that's it. Okay. Okay. If we have Power BI, I guess I answered the question. Matching. Okay. I did not get the answer to my question. Okay, I'll come back. Just give you all a brief overview, because if you are not able to answer the question, maybe I rushed a bit. So I'll just go back for what we were discussing. So we discussed that out of all the areas in London, which are the areas where house prices are the most expensive? Same thing we discussed for England. Out of all the areas in London, which are the top three areas which have the highest prices? And then we compared that if I compare the top three house prices areas in in England, with the lowest one in London, we see that there is no significant difference. Thus, we can infer that overall house prices are very much higher, and it has grown exponentially from 1995 to 2019 in London. That was one finding that we did in as part of our data exploration. Second thing that we move now is houses sold. Now, what we want to identify is that in London, out of all the 33 different areas, which are the top five areas where most number of houses have sold? And now we understood that. But rather than plotting that on a graph like this, what we want to do is we want to plot graph of London area or England area, and out of all the 33 areas that are there, I want to visualize this. In order to actually plot a map, we needed to have a data set. Geospatial information is something that we needed, and for that we read this. A lot of people ask this question, that why are we using GPD? And I told you also that in order to read this kind of data, which involves geometry, which involves geospatial information, we need to have GPD package imported. And this is the data that we are merging. We have that data which deals with all the necessary information that is there for London area. What is the price, what is the year, and all of those things. And in this particular area, if you see that for all the area, what is the hectares and what is the geometry? So it deals with the geography related information. That is why we are merging these two data, so that for every area of London, we now have details of date, price, unit sold, as well as we also have details of this. What is the code, area code of that particular area? How many hectares area is that? And what is the geometry? Like what are the actual, if I see on maps, how actually it is distributed. So that is why we are merging the data. So that was my question, as in why are we merging these two data sets? Okay, and answer is here. So now you see, I have area, I have code, I have hectare, I have geometry. What I had here, this thing. And also I calculated area, average price, and houses sold. For every area, what is the average price of houses? And for every area, how many houses sold in this particular entire duration of 1995 to 2019? And after merging, I see 4 plus 2, 6 columns that are there in this particular data. That is the output of my merge. How do we go for merge? Merge is a very simple, has a very simple syntax. You say pd dot merge, and this is one particular data frame, this is another data frame. How do you want to merge it? If someone is familiar with the concepts of joins, then you would understand this concept of inner. But I'm assuming not every people know the concept of joins. So I'll tell you what actually inner join means is, I have one data, I have another data. I say do a inner join. So there would be one column which is common in both the particular data sets. In our case, The common column is area. If you see here, we have area in this data also, we have area in this data also. So the necessary condition to merge any two particular data set or to do any kind of join is that both of the data sets should have one common column. Now we have the common column. Now what we say is do an inner join. Inner join means only those data set, only bring me those rows from 1 and from 2 which are common in both. I don't want anything which is there in 1 not in 2, or maybe which is there in 2 or not in 1, or not in either of these. So inner join means, or inner merge here means, that only the common rows from both of the data sets would be the output of this particular result. And like you see here, right, I said there has to be a common column. And this is a syntax, you have to know how to write this particular code. So we say on, and inside on, you can write which are the columns which are common. It might happen that there is no single column, there are multiple common columns. So in that case, you can just write the column name separated by comma. In our case, we only had one common column on which we wanted to join. What kind of join? Inner join, and we merged. Okay. Before moving forward, I just saw a question in the chat that what is the difference between data sets and data frame? Data set is a very common terminology that we use. But if I want to explain is, initially, if you remember, I did pandas.read CSV. Here also I did GPD. If I go here, read file. Any data that you are reading, it can be a file, it can be a CSV, it can be a JSON, and there are n number of different file formats that are there. These are data sets. The source data that we are reading into our system is what a data set is. While data frame, if you remember, I even created a slide for that. What a data frame or is a functionality that is there in pandas which are used to store multi-dimensional data. Or I would say it is a multi-dimensional table comprising of rows and comprising of columns under pandas package. So that is the difference between these two. Data set is different, data frame is different. This is what, so if I give you one line example again, if you see here, this is particular location that is there. So this particular data set, this is data set which I am reading because I am doing a read file. And where I am storing this London map, this is a data frame. Again, another example, if you see, all of these are data frames. And this, what we are reading here, is a data set. I hope that question is clear. Okay. If we have Power BI, I guess a lot of questions on Power BI or Tableau. Okay, let me answer the questions on Power BI and Tableau because I guess that is something that is hindering all of you. Okay, so in Python, we have the functionality of performing exploratory data analysis. So be it NumPy, be it Pandas, that is not only used to visualize the data. If you see here, if I go back to my screen, and let me give you a smaller example. Okay, so I showed you that under data frames or under pandas, we have different functions. We have length, shape, head, tail, describe. And while we are going on, a lot of functions are coming and I'm telling you what these functions are. So like these, there are hundreds of functionalities that are offered under pandas package. Same for NumPy. And for this one, this visualization thing, Matplotlib is a package which offers you different visualization tools like PyPlot, bar chart, pie chart, all of these things. So one question is, I want to create a pie chart. There are two options to do that. I'll go ahead. I'll use this matplotlib.py. Let me show you. Matplotlib.py, and I'll create this. I have the visualization for pie chart with my given data set. Another way to do this is I'll import the data in my Power. I'm taking an example of Power BI. I'll import my entire data into Power BI. I'll just do a drag and drop, and it will. I don't even need to write a single line of code. That is the difference. So here, if you see, I've written this much data, this much code here to generate this pie chart. There, I don't need to write a single piece of code. I'll just select, okay, this is my data set. This is the visualization I want. It will create it for you. You just need to do a drag and drop. Now, Why, when do we use this and when do we use that is something that you might want to ask. So while we are doing exploratory data analysis, so in this entire project that I'm showing you is exploratory data analysis. From starting, we did data pre-processing, that then we are doing all the way, we are only exploring the data and exploring the data. And in between, like I told you, right, all of the visualization were not necessary. Okay, let me go back and I'll show you one thing. Okay, so I did this thing, if you remember. I selected the top three most expensive regions in England. These are the top three most expensive regions in England. Then I went ahead and I plotted this thing on a visualization tool. If I did not had done that, you still had known through this particular piece of code that okay, these are the three top area-wise expensive regions in England. But by visualization of these three things, you get a lot of hidden information as well. And understanding a picture is very much easier than understanding data. That is the reason we implement these visualizations. If you want to go for a Power BI, then there is a extra step added. You want to like pull the data into Power BI and visualize and everything. So, if I tell you about a real life scenario, like how we work in companies, is if we have a particular use case, first of all, we try to understand and explore the data using Python packages. And once we are done with that, the analysis part is never done on Power BI or Tableau or anything. Analysis is never done that, is never that done using that. Once we are done using analysis and a lot of questions get answered, we are able to understand, okay, this is how data looks like, this is important, this is not important, this is what we need to filter out and everything. Once that is done, then later in time, if I want to create a dashboard, like suppose I want to see the trends that is ever changing with the change data and everything, then in that case, because it also has a lot of good functionalities, don't need to write and pie chart and everything is already made. So in that case, you can use that. But you need to differentiate when do we use this and when do we use that. As per the use case, you can use either of those. Everything is offered there also. Everything is offered here also. It depends on how much you want to use. Okay, I think okay. One more question. What's the difference between a library and a package? Very good question. Okay. Rather than theoretical answer, I'll try to explain this with an example. This is a package. When I say import NumPy, NumPy is a package. Okay. So everything, a lot of different libraries or everything that is Python, I would say, is a bigger Venn diagram. Libraries or something that are there inside that package. So in order to import NumPy, you say import NumPy. But there is also a thing called math. There is a package called math. I say import math. So inside math, there are different functionalities. I want to calculate the square root. I want to calculate pi value and a lot of these things. So inside that, I can go ahead and use either of these things. But overall, you have to first of all call a package. Inside package, you can use different libraries. I'm very glad you guys are asking this question. It shows how attentive you are. How do we? Okay, if you have Power BI or Tableau, I guess I answered this question. Why are we using these things? My question is how Pandas, Python, NumPy, and Power combined help me. If you can help, it will be very useful. Okay. I guess this question, Abhishek, that you're asking is something I want to showcase you this thing. That Pandas, NumPy, Python is not different from Pandas and NumPy. Pandas and NumPy are a part of Python. And all of, if you're seeing currently, what I'm doing from starting is I'm using all the functionalities of Pandas and I'm using bit of functionalities of NumPy as well, which are provided under Python to do data analysis. Once I'm done with data analysis, maybe someone comes to me and asks me that, okay, Shelja, I now understand that, okay, you have understood the trend, I still have not reached at the end. I'll give my conclusions of everything that you just ran through currently. What is the output that you got? But let's suppose we understood, okay, we had two questions at the start. We are able to answer these questions using a lot of exploratory data analysis. Now someone comes to me and asks me that, Shelja, now I want to see a dashboard where I want to see all of these trends. So suppose I have a data set currently, And these data set, if you see, right, it has 1995 to 2019 data only. 2020, 2021, 22 data is not there. Maybe 10 days later, the data got changed, updated. Now my visuals would look different. So I want to create a dashboard which gets changing as per the data set that is there. And that is something maybe a client wants to see or someone wants to see. So that is where I'll use Power BI. So in real life, in our data domain, this is how we use all of these functionalities combined for EDA as well as for creating dashboards. Okay. Okay. I guess, yeah, maybe I'll take some questions later on and I'll proceed forward. Where was I? I just need to scroll a bit. Okay. Okay. We understood about the intersect 1D. Now I did a merge. I explained you the concept of join. We understood the concept of inner join. We understood the concept of on. We understood the concept of common column. Head is something I guess everyone is now familiar with. Now, again, very good function called type. I guess we saw that previously itself. But yeah, recalling that, if I have a data frame and I want to understand the data type, I just say this is my final data frame that I created by merging these two. You see here, there is a data frame type called geo data frame. Normally we say, okay, data type is string, data type is integer, data type is double, float, all of these things. Have you ever heard of geo data frame? No. Why is it geo data frame? The reason is that the data that we read, the second data set that we merged our data with, was having geospatial information. That is the reason the new data frame type is geo data frame. And unless you have data frame type as geo data frame, you cannot plot the map which I am about to plot. So that is why this entire process of reading the data, merging the data was only to create a final data frame of type geo data frame. Now, let me just quickly show you that what I actually wanted to do. So now this looks very fascinating, right? Now I have the map, and this is a map of the city of London. We are only considering London. So rather than all of those things, now we see something in terms of area. This is overall 33, what we have been seeing as areas, browse, different terminologies. So these are all those 33 areas, and same as this plot shows that what have been the average house price from the year 1995 to 2019. And this particular diagram shows that for the same timeline of 1995 to 2019, how many houses have been sold in exactly same 33 areas. And this is a particular scale on color scale. If you see, the darker the area, the more is the density. Same thing, the darker the color, more is the number. So if you see, this area has the darkest color in terms of average house price. And if you remember from our findings, which area has the highest price in London? It was Kingston and Chelsea. And this is what this diagram also shows you. Rather than name here, I see the location of that particular place. That this is the Chelsea location which has the average house price which is highest. While on the other hand, you don't see same location. If I see this is Chelsea, Chelsea is having light color, which means I know that this area has the highest price, but this area number of houses sold are not highest. I see these are the darkest colors, and out of these three, this one is the most darkest. And which one is it in terms of my this one? This is Barking and Dagenham. Sorry. So this is this area. So same thing that we did in terms of those particular visualizations, I included geospatial information. And the reason to include geospatial information was just to have this particular data. Now, this is very much useful to understand from a geography point of view. That I see London, I see 33 areas, I see the distribution. Now I see which is higher, which is lower, and how it is reducing. Same thing for houses sold. Now, coming back to how we plot this. Now, there is we just place this. We have to create two different. So I say that okay, plot this average price. I say I am picking a color, and I am picking a color blue for this one. And then these are all just title and all of these things. So again, I'm plotting. Plot. If you remember, I've been talking about matplotlib multiple times. Hover over this and you can read about it. It gives you all the information of how actually we can implement PyPlot. So this is also like a very useful scenario for someone who wants to visualize the data. These are all the inferences I draw. First inferences is, like I said, we can see Kensington and Westminster are the dark boroughs in the first map. This one is the darkest borough in the map. Then, and we can also see that, okay, this is the most expensive. Second thing is, all the areas around this particular area is also expensive. And as and when we move bit distant from this area, you see the graph gets lighter. So you see that, okay, now the areas are not that expensive. This is a very good feature if you see, right? This can only give you, okay, this is the name and everything. From all these graphs, you see, okay, this is the name and everything. But if I go come here, I see the map of London. So I can visualize, okay, this area has price. That is why all the areas near this particular area has higher price. And that is why all the areas which are not so near to this area have lower prices. Second is, number of houses sold affected by many of the areas, one of them into total area, each of the borough. So if you see one thing here, this is a very common scenario, right? If houses prices are high, the number of people buying that would be low. That is something even a layman can tell. That if I go ahead, if I want to buy a place, where will I buy? I will go and buy at a place where house prices are low, right? Rather than at a place where house prices are very high. So same thing you can see is here house prices are very high, but the number of houses sold are comparatively very lesser if I compare with other states. And same thing for the areas which have very lower prices. In that case, the number of houses sold are very much higher. So these are all the inferences that you can draw from this particular visualization. Now, till now, what we were doing is we understood, okay, house prices are increasing, house prices are decreasing, which are the areas with highest number of house prices. Then we understood which are the areas where a lot of houses are sold, which are the areas where lesser houses are sold, and everything. That is everything that we understood from one data source. Now, my second question is, I understand the trend, I understand everything. Now I want to ask you this question, that why? Why this area has higher range of prices? Why this area, second area, has lower range of prices? Anyone who sees a visualization might ask this question. Now for that, I have a third data set. This is the final data set. And first of all, I'll read it to understand how it looks. Okay, so this is my data set, which I have stored in my local. I read this using read CSV. Now, I have this entire data set. The first thing that I want to do is I want to only select that data which has only London data. And if you remember that we had only 33 different areas in London. So from the entire data set that we have read, I put this condition that out of area, it should only be the one that has, this is a short form for London boroughs. So if you see, one more important concept that I just forgot to mention is the concept of comments. A lot many places, if you see here, there is a green color code that is there in my code. This is comment. So why do we use comment? Comment is a line of code or multiple line of code that we can write in multiple languages, including Python. And what happens is, how it helps is, it gives definition of what you are doing. So if someone who doesn't know anything of the piece of the code, what is happening, what is not happening, and all of these things, if I write a code and after that I write a comment that, if you see here, I've written select only London boroughs. So this gives me information that, okay, this line of code is actually selecting only London areas. So this is the usefulness of comment. Comment never gets executed. All of these lines of code will get executed. Comment will not get executed. Comment is only for the purpose of documentation. That is why comment is very helpful. In Python, all the comments start with hash. So if you are someone who is planning to be a Python coder, this is a very good tip, that always use comments in your piece of code. Okay, moving forward. Now, I have the entire data. I have filtered out the London data itself because now I want to go deep into my exploration. First thing is, I want to see the data. We are talking about multiple times. That is, I'll go and see the head, only few rows. That is top 5. Because I have not mentioned anything, by default, 5 rows it will give me. Second thing is I want to understand how many rows and how many columns are there. So this is a way to write that out. Shape is a function. Shape 0 gives me the number of rows. We saw that earlier also. And shape 1 gives me the number of columns. I'll just go ahead and print that from that particular thing. And if you remember, I told you, right? Data set and data frame. So that is why print data set. The data set that we have read, it has 693 rows and 12 columns. Okay. Now, if you see there are so many columns, I see code, which is area code. Area is the name of the browse. Then I have the date for what particular date this particular entry is. I see median salary. Median salary gives me an idea that, okay, in a particular area in London, for the people who are earning, what is the median salary of the people earning people in that particular area? Then we have life satisfaction. I think this column already NAN means NA, NAN, null. These are just synonymous to having empty values. Then I have mean salary, median salary. Then I have different columns: number of jobs, area size, number of houses, borough flag. It has to be one if you remember. For London, borough flag has to be one. What is the population size? How many people are there in that particular area? And recycling PCT. Like basically, we have 12 different columns, which gives details, lot much detail of a particular area. Previously, we only had details as in what is the area size, what is the area uh, prices, and all of these things. Now we have more details. So what you can see here is, first of all, if you remember, whenever we are reading any data set, the first step to do is a data pre-processing. I told you that, I'm repeating that again. If you're someone who is noting it down, please note it down that whenever you are reading any data sets and you are about to perform data analysis, always start with data pre-processing and then go for data exploration. So if I want to explore this data, first of all, I want to understand whether this data is good enough to explore or not, whether it has nulls, it has inconsistencies, and all of these things. So how do we do that is we'll just go ahead, we'll see, okay, these are all the null values. And same way what we did was we identified all the null values, and second thing is we identified what is the percentage contribution of the null values. So what you see here is out of the 12 columns, there are so many columns which has null values. So earlier I told you, right, there are two steps. First is identify the rows which has null values, drop them, or if you're not dropping them, second thing is you might go ahead and replace the values. But that was we had only had two columns. Here if you see we had 1, 2, 3, 4, 5, 6, 7 columns. Out of 10 columns, 7 columns have counts, have null counts in those. And out of this, one column specifically, life satisfaction, has 63% empty values. So, in that case, we have to do something because we can't go ahead and replace the mean values every time. So, there the concept of correlation comes into picture. Very, very important concept of correlation. So, I have tried to write the explanation for this, that we see that they have multiple missing values. This concept of correlation I'll be using a bit later on, so just stick to that. So now this concept of correlation will help us to go for pairwise correlation, and in that case the values which have empty or something, we can actually ignore those. But how we do that, I'll talk about that later. Okay, that was just to give you an overview that how we can implement the third way also in cases where we have multiple columns which have null values. Now, okay, so sorry. Second thing. First thing was, if you remember, in data processing, the first thing that we did was missing value analysis. Here also we have done the missing value analysis. We have found something, and the solution for that we'll implement later. Second thing was to understand the data type. If you remember, we extracted date from a year from the date column that we have. And here we have seen that there is a column called mean salary. If you see here, mean salary. There is a column called mean salary. So since I have already seen the data set, what I have seen is this particular mean salary column does not have one particular data type. It has a mix of a lot of things. This is also one of the very important use case, and I would say this is something that every data person has to firstly do. That whenever we have the data, there are few columns whose data type is inconsistent. Like, I'll give you an example. We have a column for name. Name always has to be a string. But you see that of all the data, there are few particular entries where you see 1, 2, 3, 4, 5 as a name, which should not be there, right? So data type inconsistency is something that you see multiple times. So how do we deal with that? Now, I first of all try to see that from this particular data frame, from this particular column, is there anything which is numeric, which is non-numeric? And since I have said non, this tilde symbol, if you see here, this is a tilde symbol, it gives you negation. Anything that you say, if you put tilde in front of it, it will give you the negative output of that. So I see here that there are 7 particular entries which are non-numeric. So I have to do something for that, right? So first of all, I cannot directly convert. First of all, I know that there are a lot of entries which have hash in those particular salary cannot have hashes. So what I'll do is I'll replace the hashes with empty value, because I don't know what to replace. So in that case, I'll just go ahead, I'll replace hash with empty values. And now once I have that, then in that case, I'll convert it to float. So I had data inconsistency. I had to convert it to float type. Before that, I understood what are the different inconsistency that is there. In my case, the inconsistency was it has hash value. So first, this is a second. Yeah. So in our case, we had hash values. So what we did was we replaced hash values with empty values. So now everything is consistent. And now I go ahead and convert all the columns into float. This is not a strict formula that all of you need to follow, but the strict formula that you need to take away from this particular example is that whenever you're reading a data, make sure all the columns have a consistent data types. When I say consistent, what I mean is if I have a column called string, all the rows should be string only. There should not be any number or there should not be any float or anything of that. So data type inconsistency is something that you have to check in data pre-processing stage itself. Now, I just want to identify that the new data that I have read currently, how many years data it has. So what I'll say is, I already told you, right? There are a lot of math functions. One is min, another is max. So like suppose I have a column called year. I have 10,000 rows in that particular column. What I want to see is what is the minimum value in that particular column and what is the maximum value that is in that particular column. So what I do here is same case. I say from this particular data set, first of all, I will extract the year. I don't want the entire date column. I will extract the year. I will save it in a different column. And in that particular column, I'll say dot min and dot max. It gives me, okay, minimum is 1999 and maximum is 2019. So this confers that whatever I've been doing in the previous data set, I was showing you guys multiple times that all this data set is from 1999 to 2019. Same thing we can confer here also, that the new data that we have read right now, it has data from 1999 to 2019. So min, max, average, sum, these 4 5 functions are the most used one. So yeah, okay. Now, okay, I have 1999. This is just a reset index column that we already understood. Okay, so now what I've done is for each of the area and year, I am calculating the mean. So for each of the area as well as the year combination, I will calculate the mean value so that I can later place it and understand what is the what is the reason why it's changing so much. So again, I have to merge the data so that I can have all the things. I now have year, median salary, like this is the data that I read. And if you remember, average price and household is something that we have been bringing since start. So all these things that I did in the previous step was just to make this data similar to the data we have to merge. Then we go ahead, we merge it. All the things are somewhat similar. If you don't need some columns, you can just go ahead and drop those columns. Now we have all this data. Now we'll go for correlation. How we use correlation? One directly, one simple function, CORR. If you want to read more about this function, the best way in Visual Studio is hover over that and it will give you all the details. What are the parameters, what it returns, and all of these things. Now, I just say you this thing that this was my data frame. This is the correlation. Store it in a table, and it will give you the correlation score. Okay, I'll give you just a summary of what correlation is. Correlation values can go from negative to positive, that is lowest correlation to highest correlation. What I mean here is how much two things are related. As in, there is a thing called price, there is a thing called year. If I say how are these two variables correlated, higher the correlation, higher is the dependency. As in, price increases, salary. Let me give you an example of year and price. So if I say year and price are highly correlated, which means as and when the year increases, average price also increases. Same way, if year decreases, average price also decreases. That is the concept of correlation. Two variables are correlated as much higher they are, as much as they are affecting their values, and as much lower they are, these two values are interdependent. So that is the concept of correlation. So these are all the outcomes that we can draw from this particular correlation diagram that we saw. First thing is, it doesn't come as a surprise that apart from year, average price in London has a significant positive correlation with the median and mean salary and number of jobs in a borough. So I guess I've created the diagram also for this for better understanding. So numbers are less understandable rather than diagram. But one thing is, if you say that for this particular area the prices are very high, the reason for that, if you want to understand, I just created this correlation diagram. I see that the mean salary and the median salary have a positive correlation with the price, which means salary of the people of that particular location is very high. Number of jobs also has a positive correlation. If you see, number of job is 0.48, median salary is 0.58, and mean salary is also 0.48, which means salary is high, number of jobs is high. That is why average price of London area is very high. So your question to why is that particular area price is higher, correlation gives you the answer. Second thing, there is a small positive correlation with life satisfaction. So if there is not something very detailed, we cannot draw influences, but what we can see is life satisfaction is 0.27. So, but we don't have much detail, so we cannot bring any conclusion. But what we can say is for areas having high prices in houses, life satisfaction is also positively correlated. Now, happen to be small, which explains the negative correlation with the size of an area. Okay. If you see the area size is negative. Prices are higher, sizes is negative, which means smaller the area, higher the price. And you can also, if I go back here, right, into the diagram that okay, if you see here, the highest price area was this one, which is a very smaller area. That is also something that you can draw inference from this correlation diagram that we created, that the area size is negative. It is negatively correlated with the average price, which means smaller the area in London, higher is the prices. That is again one another conclusion that we can draw. And lastly, you can see that average price is also affected by the number of houses sold. Number of houses is negative. Since the former goes up, later decreases. This is the number of houses, which is negative, and average price is higher. Lesser number of houses are sold, higher is the prices. So these are all the reasons which you can infer from this correlation matrix, that okay, these are the reason why London has so much high prices, because of higher in positive correlation means that is directly affecting it. Negative correlation means there is an inverse effect. One increases, second decreases, and vice versa. Okay, this is something that is a, I would say, numerical representation of correlation. For correlation, it is always advisable to go for a heat map. Heat map is a visualization tool, so it gives you a very clear picture of positive as well as negative correlation. So here, how do we go for that? I say SNS is another module that is there. There is heat map function that is there in SNS. So I go ahead and I plot this. So you see here that for 0, this is the color. More the positive correlation, darker the blue color, lesser the correlation, like it's getting lighter and lighter, it means negative correlation. So all the things that you just saw here in the form of numerics, you can see that in that heat map. So yeah, just one advice: whenever you're going for any kind of correlation, you have to use heat map. Like have to, as in this is very much simpler to understand. So what did I say was that okay, I see number of jobs and houses sold. One second. Okay, this is houses sold. I want to understand houses sold as well as the average price. So you see, average price and the mean salary are positively correlated. Average price and mean salary. This one, average price and mean salary, 0.48. Again, average price and number of jobs, again, positively correlated. Average price is negatively correlated with area size. That is why it is very dark in color. So wherever you see dark colors, even if I don't go into details, if I see dark color, I just understand that okay, it means they are negatively correlated. One increases, other decreases. Houses sold is negatively correlated to median salary. Higher the salary, lesser are the number of houses sold. Higher the salary, it is a positive correlation, so higher is the average price. So all of these things you can inform from this correlation matrix. There is another way to do this thing. This is a scatter matrix. This is just the same way to visualize correlation. There are two ways: heat map or scatter matrix. My personal preference is heat map, but I always want to give you options, so you can go for either heat map or scatter matrix. It will give you an idea of how things are correlated. So here, if you see, right, how do you want to visualize that? Okay, which is what? So if you see, this is a straight line, kind of a straight line. And here, if you see, it goes more on left, it goes more on right. So more on right, positively correlated, more on left, negatively correlated, and this is equal correlation. So this is how what you can see through scatter matrix. So these are either ways through which you can visualize the correlation. Okay, so this is what bringing me to the end of this particular project. If I scroll back to the top, let me scroll back to the top. If you remember, I had two questions. First question was, how has the housing market, average house price and number of houses sold changed over years in different boroughs of London, and how does it compare to England? We understood from 1995 to 2005 in different areas of London which were the top one in terms of average house prices, which were the lower one, which were the one where number of houses sold were higher, which were the one where were lower. Then we compared the same with England, and then we even identified that the top three England most expensive areas are nearly similar to the lowest like cheapest area in London. That was the first conclusion that we draw from this. Second is what factors affected it the most. We took into account all the different factors. We plotted a correlation matrix, and we were able to identify that areas where salary and as well as the number of jobs are higher, the prices are higher, and because they had positive correlation. We also saw that there are other factors which have negative correlation. One is higher, one is lower, and we were able to identify all the factors which were responsible for affecting the price and the number of houses sold in a particular area. So you have just a CSV. If I give you a layman term definition, initially, if you remember, we had two different data sets. Third data sets we brought in. So you have two different Excels. You have nothing. You just have two questions. You do data pre-processing, you do data exploration, you do exploratory data analysis, you use different visualization tools, and now you're able to answer a lot of questions through those particular that actually is data analysis. And that is how we can use Pandas, NumPy, and Matplotlib to implement all of these things and get answers to our question. So this is the overall that I just talked about. I'll go back to all the questions. I think you guys would have a lot of questions for me, so that I'll be happy to answer. Okay, let me see where I missed you guys. Okay, meanwhile, while I'm going through the questions, I would suggest everyone, please type in your questions so that I'll try to answer each of those. Okay, do we do pre-processing on data set to get that particular data frame? So Anjali, answering to your question, you have a data set, you read that data set, you already have a data frame. We do pre-processing just to clean the data. We do missing value checks, we do data type mismatch checks, and all of these things. That is data pre-processing as part of data cleaning. Unless you are done with that, you cannot go for data exploration. If you go for that, right, the output that you will get from data exploration would be not correct. That is why we go for data preprocessing. Okay. Do we need to know machine learning for analytics? No. Machine learning comes later into picture after analytics, but initial for data analysis, machine learning is not something you need to know. Ma'am, how to handle null values with different data types? Null values don't have data type. Null means null. They're empty. So column has a data type. Values don't have a data type. If you have a column, suppose it has a string data type, and you want to deal with that, there is a function called drop na. There is a function called is null. So there are different functions which you can use to identify. You can use to fill. You can use to drop. Okay, ma'am, how to read document file in Pandas? There are different ways to read. Read CSV, read file, read JSON, all of these you can use. As per of the data type, there is syntax for that. Okay, how can you put label for all the countries on map? Altaf, that is a very good question. That particular heat map, no. The geospatial information that we plotted using PyPlot, there are different. I only use three different views that labels on x-axis, label on y-axis. But if you go ahead and read more about it, there are different features through which you can actually put labels for countries as well. Okay, okay, mm-hmm. Okay. Pandas profiling is best used for analysis. Yes, it is. Mostly we use these profiling tools only for analysis. Okay. Okay. Mhm. Okay. Is null is NA? I already told null, NA, empty values all are similar. Okay. Are there any difference uses between NP array and Python list? Already told you. Okay. Repeating that again. In list also you share you can store data types, numerical data types as well as non-numerical data types. In NumPy, you only store numerical ones, but NumPy is comparatively 50 times faster to list. Now, you might ask me this question that why? The reason is how they are stored in memory. NumPy array are stored in contiguous memory location. That is why reading and writing is very much faster. While on the other hand, lists are not stored in contiguous memory location. That is why NumPy arrays are comparatively 50 times faster to lists. Analytics is a part of data science. Data science consists of a lot of things. Analytics is surely a part of that. If you are learning only analytics, then you can go ahead for data analysis roles. You're currently working as a web developer, Django. Is it best to switch? See, I would say best. Uh, that is your personal preference. But if you have interest in data analysis and all of the things that I showed you, that was just an overview. There's so much to that. So you can surely share. Okay. I don't see any more questions. What is scattered plot and see, these are all visualization tools. I would say visualization facilities that are available in matplotlib, sns, and all of these, which you can use to understand the correlation. If you are going for any kind of correlation data and you want to understand, then these are some features, some visualization tools that you can use to understand. I also wanted to share something with you in terms of roadmap and resources, what to learn, what not to learn. So I'll wait for all of your questions to end up so that I can share. Yeah. Thanks, Abhishek. I was about to answer that. Salary wise, yes, surely. Data domain is something which is very much offering. Okay. A lot of people have been asking me, what is your name? Can we connect with you and your LinkedIn profile? So on that part, I'll request Coding Ninjas team. They'll share with you all of you my LinkedIn profile. So you can connect with me there. And my name is Shelja Mishra. Okay. I see a lot of repetitive questions. So before ending the session, I'll just give you guys what you call as tips. So if you're someone who is aiming to make into data domain, so the first suggestion that I give to anyone is you have to be proficient in one programming language. And you might have understood till now that my personal preference, even the companies prefer Python. So start your preparation around Python language. Understand Python till breadth and depth, specifically the packages that we talked about, NumPy, Pandas, and Matplotlib. Understand the concepts of exploratory data analysis. And like I showed you in one particular example, the best way to practice is take one example, perform analysis, answer a few questions so that you can understand all the things inside that. After Python comes SQL. SQL is also very important because in our day-to-day life, we as data person use SQL very much to query big set of data. So end-to-end understanding of SQL is also very important after Python. Then comes which particular niche you're selecting. If you're going for a data analysis role, then in that case, you have to understand the concepts of statistics, starting with the basic concepts, what is standard deviation, what is mean, median, mode, all of these things, and going to correlation and all of these things. If you're someone who is planning to go into data engineering, then in that case you have to understand the concept of big data, Hadoop, Spark, data warehousing, all of these things. And third line, data science. If you're someone who has selected the niche of data science, then in that case you have to start understanding the concepts of machine learning and how would you integrate data analysis with machine learning. So this is something that you need to. And if you're someone who is preparing, then I see a lot of questions regarding how will you make your resume align with all of these things. Practice this particular roadmap, and as and when you're practicing, like suppose I'm practicing Python, I learned SQL. Rather than writing Python and SQL in my resume alone, what I'll do is I'll take a small project like the one I just displayed, small project, perform EDI using Python. Then I can showcase that particular project in my interview as part of a very small project, not a big project, but I can show the case that I not only learned Python, I implemented my Python skills in the form of a smaller project. So always have a two-pronged approach. Learn something, implement that. So that in your resume you can add things in form of skills as well as in the form of projects. Okay. I see my LinkedIn profile is already attached. So if someone wants to connect with me separately, I'll be happy to answer all of your questions. Meanwhile, I'm still waiting for any of your questions which I can answer. Anything related to session, anything related to career, I'll be happy to answer all of those. Can I prepare a report, PDF or Word out of the analysis? See, Abhishek, out of all the analysis that I did, you mostly see that things are in terms of visualizations only. So it's better to go for any kind of visualization. But at the end, if you want to convert your visualizations or in your dashboards into a PDF or a Word file, it's easily convertible, not an issue. Okay, thank you so much for the people appreciating. Freelance jobs are everywhere. Data analysis, data engineering, data science everywhere. It depends upon your skills and capabilities. Okay. Okay. Waiting for more questions.
I think, Shailaja, we are done with all the Q&A part. I think. Uh, okay. All right, we are done, I think. So I think, guys, we have reached the end of session today, and I hope you all have learned a lot from Shailaja. And Shailaja would have also cleared all your doubts also. And I want to thank each and everyone, especially like who is for the active participation and all. Yes, active participation and the willingness to learn with Shailaja. And special thanks to Shailaja also for his expertise in data engineering with NumPys and Pandas, right? So, is there any last thing miss you want to share, Shailaja, to the audiences so that we can close
Yeah,
the.
just end note would be that I like the enthusiasm for everyone to learn things. If you are even a college student, I would say that keep hustling, keep learning. All of these concepts may sound very big when you're learning it initially, but it's not a big deal once you start learning all of these things and always implement, try to implement all of these things. Then only you will able to retain all of these concepts.
All right, all right, all right. Once again, thank you so much, guys. Thank you so much, Shailaja, for attending, and I hope we will be getting this kind of session again in the coming future. And once again. Also, guys, one important
Sure.
notice like tomorrow there is a last day of the boot camp, and tomorrow our Ankush sir, co-founder at Coding Indias, will be joining, and he will be sharing the data science roadmap and knowledge and everything. So make sure you join tomorrow. All right. All right. Thank you so much, Salija,
Okay.
once again. Thank you so
Thank you so
much.
much. Bye bye.
Bye bye, guys.